Hello everyone. Welcome back to Learning at 11th hour. So today we are going to look at binary to hexadecimal and hexadecimal to binary conversion. So hexadecimal, what does the name signify? So we have hexa, which means 6, and decimal, we already know that it means 10. So from the name itself, we can say that there are going to be 16 symbols. So the symbols are going to be from 0 to 9, followed by, so this is 10, 10 symbols here accounted for. And the next symbols are going to be A, B, C, D, E, and F. So these are the next six symbols all put together. So 10 plus 6, we have 16 symbols in hexadecimal number system. Now, if I want to represent 16 numbers in binary, then how many bits will I require? For example, I want to represent 16 numbers. How many bits would I require for a binary number system? Binary, as in there are going to be two symbols, so 0 and 1, to the power of x, where x is the number of bits required to represent this. So let's rewrite 16. So we can write it as 2 to the power 4 is equal to 2 to the power x. Then we can take log on both sides. So 4 log base 10 2 is equal to x log base 10 2. And both the logs cancel out, and therefore the number of bits x becomes equal to 4. So we can represent the entire set of 16 symbols with 4 bits of binary numbers. So let's see how this is done. So just as we used the 4 to 1 code to understand how binary numbers can be used to represent octal numbers, we are going to use the 8421 code to represent hexadecimal numbers in binary. So if we have 0, we are going to be putting zeros in all of the positions here, 8, 4, 2, and 1. For 1, we'll put a 1 under 1. The remaining positions are going to remain 0. For 2, we'll put a 1 under 2. The remaining positions would become 0. For 3, it's 2 plus 1. So we'll put a 1 in the two positions, 2 and 1, and the remaining are 0. For 4, we'll put a 1 under 4. The remaining positions would be 0. For 5, it is 4 plus 1. So we'll put 1s under 4 and 1. The remaining positions would be 0. For 6, it is 4 plus 2. For 7, it is going to be 4 plus 2 plus 1. So till here, it is very similar to octal because the fourth bit is actually essentially 0, and the remaining 3 bits is the octal representation. Then comes 8. So under 8, we'll put a 1 and the remaining bits would be 0. After that, 9 is 8 plus 1. So we'll put 1s under 8 and 1, and the remaining bits are 0. A represents 10 over here. So that is 8 plus 2. So 10 in decimal and 1010 in binary and A in hexadecimal. B is 11 in decimal, that is 8 plus 2 plus 1. So 1011. C is 12, that is 8 plus 4. 1100. D is 13. 12 plus 1. E is 14. So that is 12 plus 2. And F is 15. The sum of all of this, 8, 4, 2, and 1, all put together is 15. So there are 16 symbols from 0 to F represented by 4 bits of binary numbers in this manner. It is not as advisable to memorize this entire sequence. Instead, we can use the 8421, and with practice, it would happen more intuitively. Now let's take up some examples and see how we can convert the hexadecimal number into a binary number and vice versa. So say I have a number with symbols picked up from the hexadecimal number system, and say there are 3 digits in the number. So say a 5, and F. Let me take it as a number with fractional part. So 0.6 C. Say this is the example. This is the number in the hexadecimal number system. I want to convert this into binary number system. Now we know that each digit in the hexadecimal number system can be represented using a 4-bit binary number. So all that we need to do is we need to know the 4-bit binary representation of each of these hexa numbers and write it out. So C here is nothing but 1100. 6 is 0110. F is 1111. 5 is 0101, and A is 1010. So putting all of this together, what we get is 1010, 0101, 1111 dot 0110, 1100. So this is the binary representation of the hexadecimal number. Now, if I want to convert from binary to hexa, so let's take up a number like 10110.01. So this is my binary. I need to know the hexa representation of it. So here we know that again 4 bits of binary represents one hexa digit. So we are going to group the binary number and split it up as groups of 4. So we'll start with the LSB over here and move from right to left before the decimal point. So this is LSB, this is going to be MSB, and it should be moved in this manner. So this is one group. And since there are not 4 digits over here, we can pad it with zeros. So it's 1 padded with 3 zeros, and I'll put that as the second group. And for the decimal part of this number, we have to pad zeros to the right. For the integer part of the number, we padded zeros on the left. For the decimal part, we need to pad the zeros on the right. So here we'll pad 2 zeros and make it as a group of 4 binary numbers. After this, the second step is to write the hexa digit representation of each of these binary numbers. So 0001 is nothing but 1, 0110 is nothing but 6, 0100 is nothing but 4. So all that this turns out to be is 16.4 in the hexadecimal representation. So here we can note that the binary representation of a particular number will occupy more memory as compared to the hexadecimal representation of that particular number. So here it's going to occupy just 1, 2, 3, 4, 5. So we need 5 nibbles of memory location for this particular number. A nibble is nothing but 4 bits. So this will require much more memory, whereas the hexadecimal representation will require very less memory as compared to the binary. So that is one very important advantage because it's very concise way of representing the binary number. And that is also hexadecimal system is also very widely used in defining memory locations. So in all the programming languages, if you see, once we run the program or once we compile the program before we run it, once we compile the program, it is going to create a hexadecimal file which is also called as the dump. So when that is created, we can see that all the instructions which we had written in the high level language gets converted into hexadecimal numbers and gets stored in the memory locations. So that's all with today's video. I hope the conversion of hexadecimal numbers to binary and binary to hexadecimal numbers and also the significance of hexa numbers is clear to you all.